webinar is going to go through some of the Allegro PCB Designer and Allegro PCB Designer Plus High Speed options that are available to you. We can actually see a full list of all the actual feature differences. So if we actually go to allcad.co.uk website, along the top is the Parallel Systems homepage. There's a matrix button. And when we click on the matrix, we actually get a full matrix for the different levels of tools. So we've got AutoCAD Standard, Professional and Designer. These are all kind of YouTube link videos to what the differences are. Kind of when the ticks stop, that's kind of up to the level of AutoCAD Standard, that's up to the level of AutoCAD Professional, and then these are the features that you would get added into an Allegro license, and then the high-speed features are available down here. And these are all videos, as I said, that you can kind of click on and have a look at. We're going to cover some of these today. The rest you can actually get from this matrix. So we'll start off with some net scheduling and creating EC sets from something that you've already created. So in AutoCAD Professional, if I was going to schedule a net, I would schedule a net, and effectively that writes a user-defined schedule into the wiring worksheet. But you have to do that for each individual net in an AutoCAD Professional-based license. With Allegro, you have the ability to actually do it once and then create an EC set from that. So we'll go through that now. So we'll start off with a net here. We'll schedule a net. So we'll go to Logic and Net Schedule, and then we'll pick the net we want to schedule. So what I can do is I can start on this device, we'll then insert a T-point, and then we'll go to device, back to the T-point, that device, back to the T-point, that device there, and then we'll go to the termination resistor once, back to that device and the termination resistor there. When I finish that, obviously my net has been scheduled, there's my T-point's been added, and I'm kind of good to go. So we'll just finish the command, and then if we go into Constraint Manager, and what we'll do is we'll look at the net routing wiring folder. You can see I've got a user-defined schedule here. We need to make sure, so if we go to the objects and filter, there's a nets of XNet, because obviously I've got XNets on this net because of the termination resistors, and I've got signal models applied. So what I want to do effectively is I want to make a rule from this EC set. So what I can do is I can literally just do a right click, create an electrical C set. That gives me a net, a name, so we'll just call it, let's just call it VDX, and we'll call it data underscore. So that then writes my constraint. So if I go to the electrical constraint set wiring, I now effectively have my template for my VDX net here. So on this example, I want to verify the schedule, and I want to add a stub length. That's by default. And we'll go back to the wiring schedule, and what we'll do is we'll just clear this, because I don't want to use this. So if we close Constraint Manager now, you can obviously see that manually defined user schedule is gone. But if I go back to Constraint Manager now, and we'll look at those, not the next one, we'll look at buses and data 1. What I can do is I can actually apply that reference electrical C set to those nets. So we'll pick my nets here. You can see they all get applied using this template with a verify schedule and the stub length. And if I then go back to the main PCB window, there's all my T-points for all of that net. So that saves a lot of time when you're automating this kind of process, having to do all this manually. So that's one of the key features of an Allegro license. The next bit is obviously if we take that rule here, what we can do is that we can actually do a Signal Explorer. Now we can do this with any level of the tools. We can actually just go and launch it with a let's pick an Allegro license, for example, Allegro PCB Designer license. I can actually go and actually see my net scheduled, so I can see all the different T-points. I can see the T-point, all the termination devices. So if I wanted to, let's just click on this and do a pulse, apply, and OK. I could actually then go and simulate this net, have a look and see what's going on, standard kind of reflection. I can look at the microstrip values and stuff like that. Resistor value and the microstrip value is different, so that's maybe some of the reasons why I'm getting what I'm getting. So I can make changes here. But with this Allegro base license, that's about all I can do from a simulation point of view. So if we just, we won't save that, we'll go back here. But this time when we take this net, what we'll do is we'll go to Signal Explorer, but we'll take an Allegro PCB High Speed license. So this is where the High Speed license starts to come in. Obviously I see the same topology, I can still simulate this, but I also now get a set constraints option, which can be really useful. So I can actually start to apply rules to this. So let's go and maybe set an impedance for all of that net. Let's set it to 60 ohms, maybe with a 2% tolerance. So I can add that rule, and then we'll go to propagation delay. And what I want to do is I want to specify a specific rule from effectively U22 back to my 2 termination resistors. So I'll pick U22 and we'll go to RN2 pin 5, and we'll set this as a length-based rule. I don't know, let's just go and set something like 3 and 4 millimeters. We'll add that rule, and then we'll go from U22 to RN8 pin 2. We'll do the same thing, 3 and 4. So we've added 3 rules to this topology effectively. So we'll apply that. Then I have the option here to do an update constraint manager. So we'll just say yes. And then if we go back to constraint manager now, it's added those rules. So we can see obviously there's my, let's go to the right place, there's the impedance, and there's my propagation delay rules here added. But if I actually go to the wiring area, we'll go to the impedance space, you can see that rule's been applied here. If I go to the propagation delays, and we'll just, let's just do an analyze here. Sorry, we need to do an expand, or actually not an analyze. You can see that the individual, if we turn the rules on, so let's just turn the rules on for these 2, and then we'll analyze this again. What's happened here is that all the individual different resistor groups have been set for the different pins on the ICs based on the topology. So it allows you to kind of automate a lot of this process, which can really speed up when setting up your design. So we'll now go and open a different board, and we'll go back to, so we've got Allegro PCB Designer license. So if we're looking at this match group, so in OrCAD we've got a match group here, for example. If we go to Constraint Manager, we look at routing, relative propagation delay, and we'll look at our DQ bus. We'll look and analyze this. You can see we're meeting all of our constraints. We're good to go. Now, in some examples, obviously, the manufacturer may well change the pin delay, so the distance from the bond wire to the actual pin on the pad. He may change that timing distance, and you'll get that as a text file, and you might want to import that information. So with an Allegro PCB Designer license, we have the ability to do a file import pin delay. So I can then browse for my simple text file, and I've got a couple of files here, so we'll pick the FPGA devices, and you basically pick the file that you want to, and then I'll pick the device that I want. So let's just turn on the top pins. So I want to apply it to that one, and I also want to apply it to this device. And then I'm going to browse for a separate text file. This one's for the memory devices, and then again I'll select memory device 1 and import, and memory device 2 and import. Once that's done, if we then go to Constraint Manager, you can see my pin delay information has actually been brought in here. So if we go to Analyze and Analysis modes, you can actually enable the pin delay and the Z-axis, so we'll enable both of those. So pin delay obviously is what we've just set from the information from the IC chip manufacturer. Z-axis, it will start to actually include that in the thickness of the PCB going through via. So we'll then do an apply on that. And then what you'll find is that match group that you had now has errors because we've got some different pin delays coming from our manufacturer. So we would then have to kind of go in and make some adjustments to these values to try and meet the rules that we need to. So if I wanted to do, manually add some delay tuning, I obviously get the heads-up display using an Allegro PCB Designer license. But let's take this to the next level. So what we'll do now is we'll change editor again. We'll invoke the high speed license this time. Now this time I'm going to turn on something called timing vision. So if I go to root and timing vision and then look at my options pane, I can actually set the color of the tracking to how the requirement is based on the timing rules that I've got. So obviously if it goes green, it's going to satisfy the requirement. If it's red, it's too short. If it's yellow, it's too long. And I get a pattern for a target signal. And I can also do like a match group selection. So if I pick one of these nets, obviously the whole of the match group here would be enabled. So we'll just do, we'll change it to, we actually want smart timing. And update goals. Now, smart timing will actually just look at all the members of all the match groups and decide what the longest routing member is and where the targets are, and then it will give you a kind of a goal value. So if I actually hover over some of these tooltips, you can see I've obviously got these are too short. The goal is what I need to do, so I need to add some delay to this to get this done. But because the track has changed colour, so this is now a timing colour. When I do the delay, obviously if I I can get it to go green. by literally just using the manual delay. But again, with a high-speed license, I can go root, and there's something called auto-interactive delay tuning. And what this does is allow me to automatically do this from a group selection. So I've just got one track here, so I'll literally just window that track, and it would then automatically add the delay there. And we can do this in groups. I can window the whole bus if I wanted to. Some examples, it might be easier just to window the ones that need the adjustment. So we'll do this one in here. I've obviously not got enough room in here because it wouldn't allow me to do that. So if I enable a couple of items, it will change both of these and get them to go green. And that's the general idea, is we're trying to get the routing to go green to allow you to meet the constraints. So once that bus has all gone green, I know I'm meeting my timing rules, so we can do a done. If we go to root and back to timing vision, we can turn our timing goals off by literally just clearing all the selections, and we're good to go. So that's kind of some of the Allegro and high-speed features of bringing in pin delay, the Z-axis, and then obviously using high-speed license for your timing vision and your auto-interactive tools. Okay, so what we'll do now is we'll drop the high-speed license, and we'll just go open another design, and we'll open something called the DFA. So with Allegro PCB Designer, this allows you to set up a rule set when you're placing components. So in general, in an OrCAD-based license, you have something called a place bounds, top or bottom, and you can, when you move these components around, you can have the placement boundary kind of touching. Let's just find a smaller device maybe. So I can kind of move these around, and if my placement boundary is touching or touching, it's fine. If it actually overlaps, I would get a DRS error to say that I've obviously made a placement error. And we use the placement boundary to drive that kind of rule. Now with the Allegro-based license, there's something called a DFA spreadsheet. So if we go to Setup, Constraints, DFA Constraint Spreadsheet, what you can do is you can import these, but it allows you to effectively browse for your symbols that are available in the design, and then you can actually set up a different set of rule sets. So obviously side to side, end to end, side to end, end to side. You can actually set up a different value for how these are grouped. There's also the ability to group these, so you can actually simplify the table by adding some classes. So I've got a connector class with all my connectors in. Discrete has all my discrete components. There's an ICs. And you can then use that functionality to drive a DRC rule, so that when you're placing components or moving components, you get like a little placement boundary. So if I pick up this component here, you see these circles are coming up, and this is meeting the rules. So I'm going too close here, too close to the side in all of these locations. So I'll probably need to rotate this resistor, maybe even bring it out, move it out to try and meet all the constraints. And you can see the different size bubbles depending on the different devices that I've got. If we go to a different area, let's come over here, and I'll bring this component. Obviously, coming downwards, that's the 0.5 millimeter clearance. To the side is obviously the millimeter clearance. If I rotate the device, that would then change. So I get the 0.5 millimeter clearance there and the millimeter clearance here. And the DFA spreadsheet allows you to kind of set these rules up using something called a DFA bound top, which is another placement shape. And it allows you to very, very quickly place your components to a manufacturing rule. There is actually a DFA, so if we do a DFA at the command line, there's a symbol update, which I can actually then go and change all my, or define the shape. So if I've just got placement boundary tops, I can use a DFA shape. It will create create a DFA shape for me based on those. And then I can also run the DFA spreadsheet. So if I go to DFA, I can run the spreadsheet editor as a standalone. So your manufacturing or your processing people can actually set up the rules that you needed to create your classes, and you can do this based on a library. So that's the basics of of the DFA features inside the Allegro PCB Designer. Allegro PCB Designer also comes with something called the Flow Planner. And what this does is allows you to effectively bundle all your rat's nests. You can see obviously I've got lots of rat's nests in this design. And it can be quite confusing when you're looking at that. I mean, this is quite a simple design really, but if you start to look at something a bit more complex where you've got, thousands and thousands of connections, you maybe want to organize these in groups or bundles to allow you to kind of see where you're going to route. So if we go to the Setup and Design Parameters option, there's a Flow Planning tab, and we've got some default kind of properties here. So there's a General tab. This is actually the size of the flow line. So I recommend you specify both of these as 100%, because this actually gives you the actual track and gap spacing for the bundles that are together. You then have some controls for what the bundles are going to be called, whether you show the rakes, And then obviously from an auto bundle, what the minimum rack count is, where the members must go, and you can obviously control if all the members must be in the same bus. But what we'll do is we'll go into IFP mode, or internet planning mode, and then I can literally just do a right click and I can auto bundle all, and we'll say yes to that, and all the bundles go. And if we go to the colors, we can actually look, there's now something called a plan. Let's just specify some different colors for this. So you can see now I've got some bundle lines based on what I'm looking at from my routing. So these can actually just be dragged about, so I can just take a connection, let's just grab the bundle, and I can start to adjust how I want this to be routed through a board. I can also edit the bundle, so if we hover over this bundle, I can do an edit bundle, and then we'll just add those additional members. So you can manually define what nets go into a bundle, and then you can then plan where you want your bundle to go. You have properties for the bundle, so if you look at the bundle properties, we can be very specific about which layers this is going to be on, and this would then change color, and then from a routing point of view, you would then route on these layers. So it could be a good experience for maybe a more senior PCB designer to plan the design and then give the design to a junior engineer to kind of follow the bundles. You can also manually create bundles, so I can hover over any rat's nest and do a create bundle, and then when I do an edit, I can then add other items to that. And you can see the thickness of the bundle increases depending on the number of nets that you have. You then have the option, obviously, if you use something like the design planning option. So if I went to File and Change Editor, let's just invert the design planning option. I have the ability then to effectively, I can then do things like creating flows and auto connect and connect all these up, which can really, really save you lots of time. Okay, so that's the basics of flow planning. Okay, what we'll do is we'll change editor, we'll drop our design planning license now. We've got a different design, and we're going to do a couple of things with some differential pairs. So first things first, with the Allegro PCB designer, we now have a new rule set. So if we go to the differential pairs, and we'll just expand all these out, we now have something called dynamic phase. So let's just analyze these quickly. So there's a static phase tolerance which is available in the ORCAD standard and professional based license, which is effectively a one-time check from driver to receiver to kind of look at your differential pair. You can also do something called dynamic phase, which allows you to effectively specify a length and then get a value based on that. And I've got quite a good example in a user guide just to give you a general idea of what dynamic phase is. So let's just go to the user guide section, go to that one. So dynamic phase, what it does is it looks at effectively the length, and then obviously every time you change corner, just by nature of kind of the physics of the way that this routes, obviously the inside track would actually be shorter than the outside track. So what this does is the dynamic phase actually looks at these guidelines and says, well, obviously every time this length gets to a certain point, they must be within phase of the tolerance that you specify. So if we go back here, what we'll do is we'll just set effectively a maximum length of maybe, let's go 7.5 millimeters, and maybe 0.5. And then if we just analyze this net, you'll see that effectively I'm now out of phase. And if we go to Constraint Manager, you can see this tooltip, which is quite nice, and you get the yellow line going down the middle that allows you to kind of find out you've gone out of phase and where you're going from the driver to the receiver. So in this example, again, I could use the root phase tune command and go along and add my phase bumps and be manual. But maybe a more automated way to do this would be to take the high-speed license, so File and Change Editor, we'll pick up the high-speed license. And what I can do here is use the root, and there's something called Auto-Interactive Phase Tuning. If I look at my options pane, I get to control where I want the phase or the shortening, lengthening, or the bumps to go. So I'm going to leave this as any. I don't want to shorten any of the pad entries, but what I want to do is just add some uncoupled bumps. And if I go to the more options, I can either add the sawtooth based bumps, or I can add an accordion style. So let's just go make a couple of changes here. Maybe go to 1 times here and 2 times there. And then literally I can just window select my 2 differential pairs, or my differential pair. You can see the phase bump gets added and my DRCs have effectively been cleared all the way through this design. Okay, so very, very quickly you can start to control that using the high-speed license. I can also, when routing a differential pair, People want to add things like return path wires, so if I'm just going to start routing this differential pair here, we'll just get out the area, get to some free space. Let's just turn on some layers up to here. So when I double click obviously to add a via, I've got the ability to just add my default kind of via pair for the differential pair, but I do have also an option to do a return path via. So if I look at the settings for this, it allows me to effectively pick the nets that I want them, which via I want to use, and then from a spacing point of view I can use some specific rules. So I've got an offset, a diamond, a rectangular, equidistant, inline, and one via. So in this example what I'm going to do is the settings, I'll leave the settings as they are. If I go to the return path vias prototype and we'll do a rectangular, you can now see how effectively I get my return path vias added when I add my vias. And we'll just do a double click again just to show you this. So let's come up to here, we'll double click again to add our vias, and you can see my return path vias are adding at the same time I add my default set of vias, which can be really helpful when you're doing your differential pair routing. The final bit I want to talk about briefly is back drilling. So Cadence obviously changed this at 17.2. So if we go to the pad stack editor now, there's a secondary drill option. You can actually start to define the back drill and the size of and the diameter of the back drill that you want when you design the actual pad stack. And if I go to the design layers, I can actually add effectively what diameter I want the back drill to be, what the clearance diameter needs to be. I can add keep out layers for the back drill. There is a whole video on back drill, so I'm not going to go too much into that. And if I then open a board, I'm just going to open the complete version of this. What this does is allows me to effectively physically see the back drill. So I can see effectively the keep out areas. I've got the whole diameter for my back drill. It shows me like must not cut layers where the back drill starts. So I've got back drill from back drill 1, layer 3 to 4, and 10 back to 9 and 8. So 9 is the layer it's going, and the must not cut layer is effectively layer 8. If we actually look at the cross section chart, you can actually output the drilling information, sorry, not the cross section chart. I've got back drill, the layer it starts, the layer it ends. I've got a must not cut layer. I've got the depth that I'm going to use, and I've got all the stub information, which is great from a fabrication point of view. This is all done automatically, so if I go to manufacture, NC, I've now got back drill setup and analysis, and I can analyse my design based on the drilling that I've got. So you can see the layers that I start and end, the cross section of the PCB, and then all the general information that I've got, and then I've got all the locations for where all my back drills are going to be. That concludes this Allegro and high speed demonstration.